All right. Today, we're going to talk about congruent triangles. So we talked about this idea of congruence a little bit already. And we said congruent means exact same size, exact same shape. Right? So what we can do if we know that two triangles are congruent, we can actually pick out which pieces are congruent, okay? And map everything that is congruent on. Okay, we should have 3 pairs of sides that are congruent, and 3 pairs of angles that are congruent. And so in this, well, actually, let's triangle. Not yet. We're not done. So if we know that the two triangles are congruent, we're going to have 3 pairs of congruent sides and 3 pairs of congruent angles. Okay, so from the diagram, we were able to get 2 pairs of congruent sides, but we can actually get everything we need out of the statement. Okay, so we said, if I look at this statement, we said xy, we said yz was congruent to st. Okay, those 2 things are in the same spot in that statement. Then we said xz is congruent to rt. Again, the letters are in the same spots in the statement. So to figure out, if I know the 2 triangles, which angles are congruent. So just from the statement, right, I can say x and r would have to be congruent. So angle x, angle r. Then I could say angle y is congruent to angle s, and angle z is congruent to angle t. So if I've got 2 triangles that are separate like this, okay, I can just list out the angles using one letter. We start getting into ones that have shared sides or shared angles, then we will need to start using 3 letters to name the angle.
Number 2, essentially, you have, since they're shared, you put angle B like 1.
Well, so if I want these 2 angles, I would have to name them using 3 letters, right? So for this one, I can name it DBC. And for this one, I can C. Okay, so why don't we do number 2 together here? So on these problems, we just want to list all the corresponding pieces. Okay, a congruent statement, which basically just says this triangle is congruent to this triangle. Okay, so we don't have a statement. We need arcs in A and D. So since those 2 angles aren't sharing any pieces, I could just say angle A is congruent to angle B. DCB is congruent to angle. Now, I do have to be careful here. Since I started with D, naming this angle, I do need to be careful and start with angle A, because A and D are the ones that correspond. So when I'm naming this angle here, I would have. So then, how would I name my 3rd pair of angles here? Say DBC. Okay. Then we want to list out our corresponding congruent sides. So I can start with the ones that have 1 tick mark. We could say AC is congruent to DB. Then if I go to the ones with 2 tick marks, these 2 out here, we could say AB is congruent to DC. And then this one here in the middle, it's the same side. Right? The 2 triangles share this side in the middle. So we still have to put it, yeah. So we're just going to say we could say CB. Okay. So now, from this information, we need to write a congruence statement stating that the two triangles are congruent. It's a little bit of right. Okay. Now, there's more than one correct congruent statement. Okay. There's several different ways that we could write our congruent statement, but the idea is to say triangle whatever is congruent whatever. Now, we need to make sure that we're matching up correct pieces here. So, somebody give me a way that I could match up corresponding pieces. So, okay, Kate?
Triangle ABC.
Okay. Congruent to DBC, you said?
No, sorry, DC.
CB.
No.
Good. So let's make sure that that matches up. So we said AB is congruent to DC, and then BC is congruent to CB, and then finally we can say BD is congruent to CA, and making sure each of those pieces match up. It looks like they do. Okay, so that's one correct way that we could have written this. We could have also said, right, I mean, technically you can just pick whatever order you want your first one in, and then just make sure you match up the pieces in the second one. So I could make the order, CAB for this one. So then, you can say, well, C matches up with B, so I would start with B, and A matches up with D, and then B matches up with C. I did, didn't I? That should be a D right there. There we go. Okay. There are correct answers that we could go through for a congruent statement here. Right? We just need to make sure that we're matching up corresponding pieces to state that these triangles are congruent. Okay? Questions? Why don't we try at least one?
Number 3, is that line like part of it? You open an angle, sort of living angles, like it's in on the bottom or top of that angle.
M is this point. What's that? Well, this is a precursor to proofs. Well, yeah, so in number 3, we don't have any of, not congruent, parallel. If I've got the same number of arrows on lines, they're parallel. So, we can use ideas like alternate interior angles here. If these lines are parallel, these angles would have to be the same. If these lines are parallel, these are the same. So let's take a minute here and try one of these. Yeah, I guess 1 or 3.
Good morning, Kansas South Wildcats. Anyone going on the sports medicine field trip this morning should now report to Mrs. Smith's class. Thank you.
So how do we name those angles?
With in number 3 here? Well, if I want to name this angle right here, I could call that LKM or MKL. Yeah. Well, if it's the same side, you automatically know it's congruent to itself. So, but you still want to write it out, but we don't have to have the tick marks on it for us to know that it's congruent to itself. So depending on which one you chose, some possible answers up here. I didn't, but I think in the directions it does actually say, describe how one of the triangles could be mapped onto the other. What's that? Okay. So yeah, I mean, we can see that, if we just reflect this one, they would be on top of each other. If I just slide this one, they would be on top of each other. This one, we would actually have to rotate it. Okay? We couldn't just reflect it because it would be in a different spot. But the idea is, for that part anyway, is that if I use those rigid transformations that we talked about in the last chapter, the triangles would remain congruent. Right? Sliding, rotating, reflecting. Okay? Questions on matching up corresponding parts. Okay, so real quick, let's take a look at the bottom there. Okay, those last couple of problems. We're given two triangles that are kind of in a weird position, and we want to find x and y from that. Okay, so just by looking at the triangles, it's probably kind of difficult to see which pieces match up, okay? But I can use my statement to figure out exactly what I need to do. So if I first want to solve for y, if I look at this angle right here, 2y minus 5 is angle D. D and A are congruent. So I know, just from using the statement, that 2y minus 5 has to equal 65, right? So when we're given a problem like this, we want to use the statement to figure out which pieces match up, what I need to set equal to each other. Okay? No, yeah, you're good. Yeah, because if we know that they're congruent, we know those are going to be exactly the same. So we would just set them equal. Right? Then if I wanted to figure this one out, I would have to solve for y first, plug y back in. Then I know EF and BC match up. All right, yeah, let me write the homework on the board real quick.